Alright, Chapter 7, Welding for Special Applications, TM58057. Chapter 7, Welding Special Applications, General. This chapter discussing welding application for the concrete reinforced steel bars, railroad crane rails, and coasting with the composite of the materials of the application welding procedure must be qualified with the suitable testing Appendix B of the personal scale within the specific process being used to be doing the welding. Must do the welding. 7.2 Reinforcement steel bars. Widespread with the large diameter of high strength reinforcement bars has been welded in place. If the very important welding is required for the hard for the impractical overlap of the bars, relaying of the surface surrounding concrete to transmit the load from one bar to the other. Yet many of the reinforcement steel bars are classified hard to weld because of the unfavorable chemical composition, hard carbon equivalent. Some of the specifications prohibit the arc welding reinforcement steels with the carbon contents exceeding of the 0.5% of the percent. The procedure for the welding splice for the reinforcement steel has been used successfully since the middle of the 1930s. The shield metal arc welding and thermite welding have been most popular methods for joining reinforcement bars for the field construction of the pressure gas of the submerged arc welding of the process of force shop welding, gas metal arc welding, and the flux core arc welding also have been successful in the past few years. When reinforcement bars are to be for concrete are to be welded, one most to determine the steel composition matching of the welding procedure. However, it does it hard positively identify with the new and used reinforcement bars, especially with those of the splices are being made with the structures can be enlarged with the amount of either the positive identification of the reinforcement bars. Positively, steel chemistry may be remaining reinforcement bars usually conform to the American Society testing material methods, with which base the requirements of physical properties often do specifically steel chemistry. Welding should conform with the American Welding Society D12.1. The specification deal with the permissible stress and the unload unit stress of the welding, effective welding areas of length, throw thickness, structural details for the welding transition bar side, the specific splice qualification or direct the splice detail of the lab welded splice with the details and interconnections of precast chem members of the American Welding Society D12.1 also discusses workmanship technique qualification inspection of the joints. B. Strength requirement. The strength of the weld is specified with the reinforced steel bars can be determined with the ultimate strength method of working with the rest method of the American Welding Society. D12.1. Table 2 describes the two joint welded metal base used with the two methods of determining strength with the both directed and indirect bolts splices. The requirement for the transition strength level is also discussed in American Concrete Institute ACI 318. Welding procedure joint reinforcement bars can be made into several ways: shield metal arc welding, gas metal arc welding, flux core arc welding, thermite welding, and pressure gas welding. American Welding Society D12.1. Section 5 details the procedure to be used with the various welding procedure. American Welding Society D12.1 with the table 5.1 shows the various type of electrode materials to be used with the three arc welding process. The thermite and pressure gas welding do not require the filler metals. American Welding Society D12.1 table with the 5.2 shows the preheating temperature to be used for the various carbon have equivalents of reinforcement bars with a different size. D. Mechanical butt slices. Splices and reinforcement steel bars can also be made mechanically. The splice method has been developed, which uses the exothermic process, molten filler metal to put in the angular space between the bar and the high strength steel sleeve with the inside the diameter larger than the overall diameter other than the bar. Since the strength of the joint does not depend on the fusion of the filler metal to reinforce steel with the sleeve, this is classified as a mechanical joint rather than a welded splice. E. Contract specification. Contract specification should include the requirements of the procedure qualification, welder and welder operator qualifications, inspection. The inspection should cover the material, the equipment necessary to conduct the welding procedure, with the qualification of the welder operator, the completed work with the records. The work qualification tests must be conducted on the same material will be used, but the actual construction requirements for the welding procedure should be covered with the material specification of the welding process to be used, position of the weld and the filler metal classification, the type of the pass from the single or multiple pass. The procedure should also include the requirements for the preheating interpass, temperature, and the post-weld heat temperature treatment is required. 7.3 Rail. Advantages of the welding railroad and crane rail joints over the several advantages. Continuous rail need to be less maintenance with wear less than rails that have joint ends of the bolted connections. Load rolls can smoothly from the joint to joint. Most rails is welded in a shop of 1/4 mile length of either the pressure gas with welding, flashing welding in the field can be done by using the exothermic process described in the American Welding Society Welding Handbook, Section 2. Exothermic welding is only the railroad welding process covered within the manual since the other processes are primarily limited to the shop welding and exothermic welding. It is the end of the rails must be cleaned. The joint faces parallel with the proper gauge for the line with the joint preheat. However, the production joints may be used in shop or other field does not necessarily produce the consistent strength, and so the following precautions should be taken. 1. Detailed welding procedures must be prepared. All procedures for the production welding must be qualified before welding starts. Complete weld should be visually inspected. If there are any blowouts or voids or welded joints should be replaced. Visual inspection must be not used for the acceptance of completed welding or internal defects or lack of fusion, slag, inclusion, porosity, and cracks might not be visible. Unfortunately, no method are entirely suitable for the inspection of the rail welds made with the exothermic process. 3. Radiographic ultrasound inspection must be included with the contractor specification. However, these approaches are not completely satisfactory in the radiographic examination. Excess metal must be removed from the web of the rail and the joint of the ground is smooth. However, since the varied thickness are still involved, the method is hard to use. The result of the may be inclusive. Portable ultrasonic inspection equipment is commercially available, but the very sensitive and improper setup may indicate non-existence and significant defect. The magnetic particle inspection is used for gas pressure welded, flash welded rail, but not suitable for the rail welds made by exothermic process. Railroad personnel generally use Sperry rail detector cars to inspect the rails where the track is being used. 4. Room to the thermal expansion must be provided with the continuous welded rail and is designed with the construction normally done with the restraining of the rail joint bar and friction at the ends, then subject to the accumulated restraint for successive ties. The rails are usually laid as to give zero restraint at all anticipated mean temperature. Short buffer rails, which are frequently installed at irregular intervals along with the track, allow a 3/8 of an inch movement for each of the rail end without bending of the joint bolts. These buffer rails will make adjustments easier when the continuous weld rail is laid at temperatures below the means. Alright, 7.4. Steel casting. Generally, weldability steel casting is incompatible with the rough route steel. Cast steels are usually welded in order to join one cast item to another route steel. Route steel items are repaired to repair defects of the damaged casting. The weldability of the steel is primarily the function and composition of the heat treatment. Therefore, the procedure for the precautions required for welding through steel is also applied with the cast steel. Similar composition for the heat treatment and strength of welded casting can sometimes be simplified by first considering the load in the area being welded, and often the actual strength needed in the weld. Castings are often complex. Special analysis may be required only on the part of the entire structure, but when the welding of the section of the steel casting does not require the full length strength of the casting. One can sometimes of the lower strength welding rods of the wires or other parts being welded on the casting can be lowered strength and linear analysis than the cast steel part. Under such conditions, the deposited welded metal usually matches only the strength of the lower the strength member. With a heat treatment electrode, the necessary welding sometimes can be done before finalizing final heat treating. After being subject to authenticizing treatment, heating above the upper critical temperature, welding deposits within the carbon contents less than 12 hundredths of a percent usually have the lower mechanical properties that they have been as welded in stress relief conditions. Welded joint design. The structural weld of the joint design of the cast steel weldments are similar to those used in the Roth Steel American Welding Society D11-1 Section 2, but the design criteria for the welding connections and listed pre-qualified joint designs. Any other type of the joint design may be qualified before being used in the structure. When designing a welding connection, one should consider the type of the welding process that will be used, the strength of the filler metal, and the welding access to the joint. Recommended filler metal. The choice of the electrode filler metal is based on the type of the cast steel being used, with the strength needed of the joints and post-welded heat treatment. When welding carbon alloy cast steels, the electrode recommended with comparable wrought steel. The steel plate should be used when cast on stainless steel, and the steels are joined to either the cast or ferritic metallics materials. The proper filler metal depends on the surface conditions. If surface temperature is low below 600 degrees Fahrenheit, the stresses are moderate with a high alloy austenitic stainless steel, such as the type 309 and 310, is generally used for the surface condition under the high temperature stresses. High temperatures and stress, high nickel welding metal, 70% nickel, 70% nickel, 15% chromium are better because their thermal expansion is closer than that of the ferritic materials. High nickel welded metal retards carbon mitigation, and this metal should be used with a technique to produce nickel dilution of the ferritic material. 7.5. Dissimilar combinations. Fabrication procedures often combine the cost of the aesthetic and the ferritic metals, the cost of authentic materials and raw ferritic materials. Each of the combination presents a distinct problem. Dissimilar metals are often used with the surface coating with the carbon steels, and there are problems in selective of the process technique causing the minimum dilution. This ensures freedom of the underbed of the welding crack and improve the quality of the surface deposit. The proper technique of the materials are similar to those of the raw materials. American Welding Society source for the welding equipment. Metal supplier can provide more information for the successful welding and satisfactory services of the weldments of many of these combinations. Data not available for these resources may have to be obtained by testing. Alright, 7.6. Coated and clad materials. Composite materials are often structured to retain special properties. The general thicker supporting layer of the base metal is bounded with the thin layer of another metal, often more expensive, which has desirable properties that may include the corrosion resistant, thermal electroconductivity, abrasion resistant, and decorative appeal. The composites are may be obtained but in several processes such as plating, cladding, lining, and weld overlay welding before the coating. One must consider how the welded metal coating metal can affect each other. For example, the welding operation may damage for the coating. The coating may adversely affect the weld. The welding clad plate or applied liner construction. Other operation must control the dilution of the welded material. One, two metals meet. The joint preparation, penetration, electrode selection, welding process, welding techniques as are important consideration of welding clad materials applied with liners. Detailed information is also American Welding Society Welding Handbook, Section 5. Galvanized steel. When possible, welding should be done first, since galvanizing over welds is easily. Steel already galvanized can be welded either to electrical arc, gas, or gas welding processes. But the zinc coating next to the weld may be damaged much that it might not protect the steel. Thus, the coating must be applied to the weld joint to protect it from the corrosion. The joint may be designed so that the galvanized steel is subject to tensile strength during welding upon cooling. The stress metal cold fracture when the molten zinc of the zinc vapor penetrates the welded joint before the weld. Therefore, the zinc should be removed from all joint surface and strength members. This should be done far enough from the expected toes of the weld to prevent such embrittlement. Light gauge galvanized sheet metal may be welded with a gas metal arc welding without substantial damage to the galvanized coating. This can be done with a forest bronze filler metal. The carbon arc process can be used with or without silicone bronze filler metal. More information on welding zinc coated steel is in American Welding Society D 19.0. Chapter 8. Inspection Procedures.